Circle Geometry, Angle at Center, Part 2 of 2. So here we are, we're back from the end of Part 1. Part 1 was the video which showed the reasoning behind angle at center and introduced the angle at center theorem. And we are halfway through doing some exercises, which we now continue. Number 5 here. Right. We have to find x. Now, notice that x is not subtended by an arc. Unfortunately, it ends here again. So therefore, we need to have a look further afield. We can say, well, what is x equal to? Well, we have parallel lines. X is equal to that angle. So we need to find that angle there, in fact. So our thought process is, well, what is x equal to? O. And can we find O? Yes, we can. O, what is O equal to? Twice that angle there. Have a look. Double arc, single arc, same direction arc. We don't have them going one way then the other. And we can find that one by alternate angles. So we're going to go right to there. B is 10 degrees. Why? Alternate angles, AO parallel to CB. That means we know O, because O is 2B, angle at center, and therefore X is also 20 degrees. Also, alternate angles, AO parallel to CB. Number 6. Pretty straightforward, virtually, because x is equal to half that angle. So I need to find that angle. So I can say, well, what is that angle equal to? Oh, well, twice x, but that's not going to help. But it does combine with other angles. There's the center. These are equal radii, so I can use my triangle theorems to find the value of O. So A1 is 40. Reason behind that? It's an isosceles triangle because of the radii. And therefore, O is 100. We have a 40, 40, and remember we add up to 180, angle sum triangle. So now that I know that's 100, this are all the triple. The arc subtending the angle at center, subtending the angle at the circumference. Therefore, 100 is twice x, angle at center, therefore x is 50. Number 7. We have to find x. So, if you look, there's the shape. Well, there's the shape of the arc. So we look anywhere on the remaining part of the circumference there for any point which has the same shape going, and there it is there. So once again, there's the arc, there's the angle subtended by the arc, and then there's the angle subtended by the same arc, same shape, parallel curve on the remaining part of the circumference. Therefore, we need to find that angle there. Well, C1 is 50, C2 is 70. You should be used to that by now. Isosceles triangle radii. Which means ACB is 120 degrees. Well, therefore X is twice 120, angle at center. X, yes, it's subtended on the circumference by an arc. There we are. On the remaining part of the circumference, there is the angle there, and it's half of that angle there. So when I say what is x equal to, I say, oh, half of that, but it's a problem because that's y. We can say, well, then what is y equal to? Not that. Nobody said the lines are parallel. So therefore, we're pretty stuck. So then I go back and say, well, what does x combine with? When I can't find anything x is equal to help me, I'll say, what can x combine? Well, it combines with the 30 to give the angle the same as that. Radii. So OAB is 50. Isosceles triangle radii, which means x is 20 degrees. Now that we have x 20, we can find y. Y is twice x. Angle at center, and therefore 40 degrees. Now we need to find Z. We can't talk about that as being an angle at the center. It doesn't go back to the circumference. But in fact, we write back to the exterior angle of a triangle. There's a triangle there. There's a side produced. Z is equal to those two angles added together. Exterior angle triangle. Therefore, Z is 60 degrees. Here's some exercises to do yourself. Pause. Try them yourself, then we'll go on with the answers. Right, we're going to do these as thought processes. X is double that. Therefore, X is 140 degrees. In this case, X is equal to that. Let's assume this is a straight line. It should tell you that, but that's 180 degrees, so therefore I can find that. So let's go for it. X. 180 minus 2x. Angle sum triangle. That's 180. So therefore, 180 minus 2x is half of 180. And if you solve that equation, you get x 45 degrees. In this next one, x 35, we'll have a look. X 35, same arcs subtending, therefore x is double that one there. So therefore x is 70 degrees. If we look at the next one, that's 90 degrees, that's x. Well, it looks like a straight line. Well, this angle here is subtended by that arc. And so is this angle here subtended by that arc. So therefore this angle is double that angle. So therefore x is 180 degrees. This one here, x, there's the angle x, there's the arc, and same direction, parallel curve, there's 120, so that's straightforward. X is 240 degrees. In this case, there's the x, and the only angle we can work at is there. Oh, hang on, clashing arcs. Have a look. There, unhappy arc, happy smiley arc. No, it's no good. What I do know is that if I find that, I can find that angle because there's an arc and there's the same direction arc there, and there's the arc subtending. So angle, angle from that arc. So therefore, I'm going to have to find that angle in order to find x. There we are. So it's 110, 220. Therefore, by angles at a point, x is 140 degrees. Right, let's do some more exercises now. This is now sort of like an examination type question. Let's have a look at them. Calculate with reasons M1. Well, what is M1 equal to? There we are. That arc subtends M1. And if you go here, that angle there. But we don't know that angle there. So therefore, we're not helped by that. So instead we say, well, what does M1 combine with? M2. And M2 we can find, because have a look, there is the angle at the circumference. So we start our thinking process. We say, well, what is M1 equal to? Twice Q2. But it doesn't help. So we'll laugh that off. So we say, well, let's combine 180 minus M2, M1 is equal to. So let's say, what is M2 equal to? And that we can find. Have a look there. So therefore we say M2 is twice Q1, angle at center. Therefore M1 is 180 minus M2, adjacent angle, straight line, 74 degrees. It's useful doing these with reasons because after in a little while you'll be doing riders, which are geometric problems where you have to prove things and give reasons, and those are quite rigorous. So let's get used to it here. Next one, we need to find Q2. So we say, well, what is Q2 equal to? Q2, what is Q2 equal to? Oh, well, we've just found that the first one is half of M1, which we've just found, hey? There we are. So therefore Q2, twice Q2 is M1, angle at center. So therefore we know Q2 is 37 degrees, half of M1. What is A2 equal to? So there's A2. Well, there is the angle, and it's subtended by that arc. Do we have an angle at the center subtended by that arc? Yes, there we are. M2, which we've already dealt with earlier. And therefore, twice A2 equals M2. And therefore, A2 is equal to 53 degrees. M2 divided by 2. Remember, we found M2 over there. M3, this M3 here. Well, M3 there, subtended by that arc. And there's an angle subtended by the same arc. What is M3 equal to? That's even better. There's an angle subtended by the arc on that side. Have a look. There is subtended by this arc. And going off the same arc is that angle there. Now we have a bit of a problem there because we know 5 degrees, but we don't know that. So we know that M3 is equal to twice QBA, angle at center. And we know that QBA is B2 plus 5 degrees. So we need to find B2. But think about it. Those are radii, and therefore B2 is equal to A2 by isosceles triangle, and we found A2. We found A2. So therefore B2 equals A2. So therefore M3 is twice 53 plus 5, 116 degrees. Number 2. O is the center. QPT is a straight line. QPT is a straight line. PT equals PR. PT equals PR. Alright, so it's isosceles triangle. So we could start saying, oh, therefore this equals that, that equals that, etc. But that's just confusing if you start filling up the figure with equal marks, etc. Rather use your thought process, use your treasure hunting to go back as from the first video that on this topic. Express x in terms of y. Now, when you're told to express x in terms of y, that means find x, and y is allowed to be in the answer. So we start by saying, well, what is x equal to? What is x equal to? Well, have a look at that. Have a look at the arc. There we are. That arc and that x go together. Now, is there an angle on the remaining part of the circumference? In other words, not this arc, but the remaining part of the circumference, which is also like this. There it is there. Aha. And that we can get in terms of y because it's the exterior angle of the isosceles triangle. So, that is twice that. What is P1 equal to? Those two added together, and they're equal to one another. So, PT equals PR, given. T1 equals R, equals Y. Now notice that once I've done my thought process, I'm working back the other way to end up with X. P1 equals twice Y1, exterior angle triangle. X equals twice P1, angle at center. And therefore X is 4Y because twice P1, twice 2Y. Now we have if TQ equals TR. So now if TQ equals TR, well, that'll give us our isosceles triangle there and there, but let's not mark it in yet. And X is 120 degrees. So we now know that that's 120 degrees. Note all the other conditions still hold. They've just given us extra conditions. Find Y. Well, that's easy because have a look at the very first one. X is 4Y. So therefore 120 is 4Y. So there we are there. Right. Now we have to find R2. And that's sitting in the middle of everywhere. It's not equal to anything. As I've said there, you see, R2 not equal to anything, so we start looking at combinations. And we can combine this one, and that one to get this whole angle there. Maybe that will help, in fact, okay? So if we can find this angle, which we know, that angle which we know, and if we can find that whole angle there, QRT, then we can find R2. That's how my thought process has taken me there. Well, R3 is 30 degrees. Angle sum triangle, you see this is 120, therefore 30, 30. QRT is 75 degrees. Have a look why. There's a 30 degree there. Therefore those two add up to 150 and they're now equal to one another. So angle sum isosceles triangle. Very clever little way of putting it. So now we've got 75 there, we've got 30 there, 30 there. Which means R2 is 15 degrees. Right, find M. Well, M, that curve, therefore that curve, going with that arc. So if I can find O2 there, I have M. Well, O2 I can find because of angles round a point. So O2 is 240, angles at a point, which is twice M because of angle at center, so therefore M is 120 degrees. All this means is that later we're going to have all of them packed together where we can practice riders, proofs, everything together, but we need to establish the few things first.